Hi, I'm Joe James, and in this video I'm going to show you how to write a Python program to do binary to decimal and decimal to binary conversion. So let's say we start out with a binary number 1011. We'll assign it to a variable called binnum. What we want to do is for each digit from right to left, peel off the right digit, multiply it by 2 to some power, and add that to the running decnum total, which is our decimal equivalent. So let's start with this outer loop. For each digit from right to left, we're going to start here on the right and work our way left. We want to peel off one digit at a time. How can we structure a loop to do this? Well, we can use a while loop while binnum is greater than 0, and then at the end of our function we can say binnum, this is integer division, divided by equals 10. So binnum equals binnum divided by 10. So that will shave off one digit each time, and this will get smaller. First time through the loop it'll have a size of 4. Second time through the loop it'll just be 101. Third time through the loop is 10. Okay, now how can we peel off the right digit? Well, we can use the mod function for that. So binnum mod 10. We're using mod 10 because Python actually thinks this is a decimal number. It's just a binary number, but Python thinks it's a decimal number. So we use mod 10 to get this digit. So mod 10 will get us the right digit, divided by 10 cuts off the right digit and gives us the other 3. Next we want to multiply that digit by 2 to some power. And the power is going to be, here is 2 to the 0 digit, 2 to the 1. The third digit from the right is 2 to the 2. And the fourth digit from the right is 2 to the power of 3, and so on. So each time we iterate through the loop, we'll increase that power by 1, and we'll start out with 0 for the first digit. So we'll multiply it by 2 to some power. This is a simple math function in Python, 2 star star, whatever the power is. Now we can combine these two statements together because we want to multiply them. So 2 to some power times binnum mod 10. So this will be 2 to the power 0 times this 1. When we get out to this 0, you'll see it'll be 2 to the power 2 times binnum mod 10 is going to give us a 0, so it won't count that at all. And lastly, we want to add that to the running decnum total. So we can say decnum plus equals 2 to some power times binnum mod 10. So that's the guts of our loop. This is how the loop is going to work. Now let's write the rest of the program. So we'll define a binary to decimal function, and we'll receive a binary number, and we'll call it binnum. Then we're going to define two other variables, decnum, which is our decimal number equivalent, is going to start out equal to 0, and the power, we're going to start out, the first time through the loop we want the power to be equal to 0, and increment it once each time through the loop. Here's the loop that we just wrote. While binnum greater than 0, decnum plus equals 2 to the power times binnum mod 10. And then we divide binnum by 10 each time to cut off the rightmost digit. And then, like we said, we want to increment power by 1 each time through the loop. And then we can return our decimal number. So that does it for our binary to decimal conversion program. So if we want to call this function, we can have a print statement, binary to decimal. We pass in a binary number. Python sees this as a decimal number, but it's a binary number because it only contains 1s and 0s. And it will print out 43. Now we want to do decimal to binary conversion, and we can use almost identical code. We can use exactly the same structure to write a decimal to binary function. Except this one we have everything reversed. So dec to bin, and then we pass in a decimal number. We set our binnum variable to 0, whereas up here we set our decimal number variable equal to 0. Our while loop is while the decimal number that we passed in is greater than 0. And then our binnum, we're adding to each time 10 times the power. Instead of up here we use 2 to the power. Down here we use 10 to the power times decnum mod 2, whereas up here we use binnum mod 10. So we basically just swapped decnum and binnum. We swapped all the 10s and 2s. And we got exactly the same functions converting in the opposite direction. So that's really simple. Except, why would we want to have two blocks of code that look almost identical? Isn't there some way that we could combine these? Well, yes, in fact there is. From num, which will be the from number we're converting from, which we'll pass in, and then from base, and then 2 base. So we need to pass in 2 more variables. If we want to convert from decimal to binary, then we pass in a 10 value for the from base and a 2 value to the to base. So let's change throughout our function here the from num, which was desc num. So we change all these desc nums to from num, and then our from base, we want to change basically all the 10s to from base here, and we want to change all the 2's in our function to the to base. So there's 2's, we change those to to base. Now we can pass in a from num, from base, and to base, and it doesn't matter if this is 10 and this is 2, or this is 2 and this is 10. We can convert either direction. So we need to make one other change. Bin num needs to be 2 num. So we've changed bin num to 2 num throughout, and then we return 2 num. Now we have a function that works both directions, right? We simply made a few changes to the program, and we've changed this function so that we can convert either from decimal to binary or from binary to decimal, depending on how we pass in the variables. So how do we call this convert function now? You can see the convert function now takes 3 parameters, a from num, a from base, and a to base. So this first call, we can say convert, and then we can still pass in a binary number, and we say from base 2 to base 10, and then it will still print out a 43. And for the second call, we can convert this to convert 126 from decimal to binary, and it will print out the binary equivalent. So I guess we really don't need this anymore, though, do we? So let's take that out. So now we have a simple little 10-line program that converts decimal to binary or binary to decimal. Or for that matter, we could do octal to binary or octal to decimal or decimal to octal by just passing in an 8 or a 2 or a 10. So that does it for our binary to decimal and decimal to binary conversion in Python. I'm Joe James. Thanks for watching.